Howdy guys, I got a few things I've got to take care of. So class is going to be starting a little bit late tonight. I've already sent you guys the emails for your wonderful take home, sending in the slides for a presentation for an undergraduate exercise physiology class. We're going to go ahead and have you guys divide up into two groups. We're going to go ahead and have, three of you guys looking at cardiovascular adaptations, and then two of you guys looking at resistance training adaptations. And so we'll just go ahead and do that alphabetically. So I believe that puts us with Alex, Diana, and Sam for one group, and then we've got Ihor and Jabari for the other. So go ahead and work together, guys. Have fun. The aerobic is going to go to Sam, Diana, and Alex's group. Now, we left off here talking about what is reesterification. And this is effectively where we're going to put back together the triglyceride by having the glycerol and then putting the three fatty acids onto it. Now, this is because we've obviously freed up what was going on there. So if we just happen to need to find a limiting factor, which is typically going to be the glycerol, but remember, we're going to create glycerol as one of those in-between steps that we're going to find whenever we happen to be going through glycolysis. So we're going to use that G3P from glycolysis to allow us to rebuild fat. So whenever you happen to be breaking or exercising, you're going to be breaking down fats. And obviously, the amount of it we're going to be breaking down is going to really depend on how quickly we can essentially break down fatty acids from one side of the body, triglycerides, and then bring them into the cell. So you're going to find that the total rate of fat oxidation is going to be relatively high, but the total rate that's potential if we didn't have this type of recycling, because we can get those triglycerides to be freed up into fatty acids, it would be far, far lower. So at rest, 70% of the free fatty acids released in the process of breaking down fats are going to be resterified rather than oxidized, meaning we're just freeing them up, we're not actually using them. Now it's during exercise, we're going to see that reesterification is going to decline massively, because now we're going to be using them as a fuel source. And so about 55% of the total free fatty acid oxidation is going to be attributed simply because we don't have as much reesterification. And in recovery, 90% of those free fatty acids released are going to be resterified because we just don't need to use them for energy. So now how does breaking down fats affect our performance? Well, it turns out whether we have a greater availability of carbohydrate or fats is going to let us know which fuel we're using. So that's the respiratory exchange ratio on the left. The higher the RER is, the greater we are relying upon carbohydrate. The lower the RER is, the more we're going to be relying on fatty acids. So as you'd suspect, high free fatty acid levels, we're using fats more as a fuel. High insulin, so that's talking about carbohydrates, we're going to be using as carbs more as fuel. And notice it's only 68%. Now, what you're going to find is that our free fatty acid levels during exercise are going to stay relatively normal for most folks, unless we happen to be giving a bolus of fat. Now, otherwise, we tend to be picking up pretty much the same rate we're effectively putting into the bloodstream, so you're not really getting an accumulation, especially when insulin's involved. Now, what we're going to find is our glucose levels, that's going to be the one that's going to decline rapidly if we happen to have a high amount of insulin. Otherwise, it's going to stay the same, potentially even go up if we're able to use a greater amount of fatty acids that are available. Remember, guys, again, this is just at 68%. So what you're going to find is individuals that happen to be relying on the fat, notice this is the use of muscle glycogen. They are not going to be using as much muscle glycogen, which is useful because we're going to retain that glycogen, and so we can utilize it later for more higher intensity exercise. So it's not necessarily a bad thing we're not using as many carbs, but it's important that the amount of fat that we have available is going to allow us at moderate and low intensities to utilize fats preferentially as a fuel more so than we are going to be utilizing carbohydrates. So we're going to increase the free fatty acids available during exercise, which is going to allow us to use that more as a fuel. And the greater the amount of fuel, the fat that we're able to use as a fuel, the more carbohydrate that we're going to effectively have left over inside of the muscle, and whenever we finish that training session, or we're just going to go for longer before we effectively fatigue out. So now when we're looking at even lower intensities, so now we're looking at only 44% of VO2 max. So this is effectively kind of a joke. And you notice individuals that were fasted are utilizing fat at a much greater amount as a fuel, as opposed to both blood glucose and muscle glycogen. Specifically, when you compare it to glucose, glucose and fat, and then a fructose supplementation. And at the same time, when you give athletes a really high calorie diet, it's not so much whether or not they're giving carbs or fat so much, it's just, are you giving them enough carbs? You're actually going to see situations where they're going to potentially increase their performance, more or less because, congratulations, they were in a caloric surplus. So in theory, they're going to go ahead and get rid of a lot more of that fatigue they had from training, which in turn is going to allow them to give a greater performance. And specifically, when you're looking at running to exhaustion in that same group with that higher fat, they were able to literally run for a further distance. And it's probably more due to the caloric surplus than it really is due to utilizing fat as a fuel. When in doubt, if an athlete has a greater amount of fuel stores, they're naturally going to be able to keep up that performance for a much longer period of time. So in general, in some studies, you do see a positive effect on fat intake for your VO2 max and time to exhaustion, but you got to be careful here, which is there's a lot of things going on with control there, and they weren't actually utilizing fat more as a fuel. So it's probably coming down to, once again, taking 3,500 calories as opposed to 3,000 calories as to being only in the 2,000 calorie range. Now, when it comes to the actual amount of glycogen, what you're going to find is, like anything else, the high carbohydrate diet is going to do a much greater job of recovering glycogen after exercise as opposed to the high fat, because you've got more carbs. And the high fat intake compared to carbohydrate is going to allow you to take in a greater amount of fat into the muscle also post-workout, just looking at the effects of specificity. Now, what's interesting, and now this is for the time trial, is notice the time trial athletes were almost 20% faster when given an acute high carbohydrate diet or high fat diet. Now, in order to really adapt to a high fat diet, we're talking about something that's going to take weeks, if not months, for some athletes to fully be able to get all of the benefits from a high fat diet. Whereas if we're looking at this, it's more the acute effect of a high carb to a high fat diet. The high carb is going to help you out because you're going to have a greater amount of glycogen. So, like anything else, guys, just we don't want to get too dogmatic about macronutrients. If you're using aerobic and anaerobic glycolysis to really be the major energy production for the athletic endeavor you're doing, you're not going to get better performance because you happen to be taking in a greater amount of fat if we're making sure we're isocaloric. Now, if you're taking in just more calories in general and more of it happens to be fat, it probably gives you a slight advantage. But if the calories are same, it's probably not going to matter. And plus, the greater amount of glycogen you have in the cell, it's not like a fuel tank. It's not like you just burn all the gas out of the tank and, oh, we're on E, we don't go fast. The key is glycogen is multi-branched. And so as we break it down, we get rid of branches. And as we get rid of branches, we're actually going to slow down the rate of further breakdown of glycogen, which in turn is going to diminish our overall energy production in those energy systems. So it's not just about keeping the glycogen, but you're going to see more of a curvilinear relationship to the speed of energy production to effectively how much glycogen we have left in the cell. So another good older research article, we're looking at individuals just cycling to exhaustion, whether or not they're doing a high carb diet, and then looking at the effects on both muscle glycogen and muscle fat. And this is really what's interesting, because as you suspect, after they got done cycling to exhaustion, they had massively decreased intramuscular levels of triglyceride that, notice, guys, it's going to bring itself back up. And, oh, sorry, this is mislabeled. This should be glycogen, but the left side is improperly named. So notice it takes a while. Notice the fat dips down because fat's actually being used as a fuel, in that the body is going to use it. So it's going to allow for those fats to be broken down aerobically to help with muscle protein synthesis, along with help fueling the ATP required for glycogen synthesis. So when in doubt, you want to make sure that you're getting in enough carbohydrate, both the timing and the volume, in order to really help maximize glycogen stores and maximize energy availability when you're exercising. Increasing our free fatty acid can give us maybe a little bit of help with allowing us to spare muscle glycogen, but we aren't going to get as much of a performance boon. But just total calories is probably going to be the first and foremost thing you really need to focus on. Now, the other thing to keep in mind, specifically when we're talking about these fatty acid metabolism adaptations, is this is something that takes a while. So just doing a short-term high-fat diet or a short-term high-carb diet, yeah, they'll give you certain benefits, but you really want to do them chronically so you can really see how does this really influence your training. And so that requires consistency, and that's going to be one of the bigger issues, which is obviously a hard thing to do consistently and to do it well in the research. So thanks for listening, guys. We will chat this over in the near future, and I will talk to you guys soon. Bye-bye.